Hi everyone, this is Unit 11, Lesson 3, and today we're going to talk about exact values and cofunctions. Cofunctions you actually did back in geometry last year. There are two special right triangles, and they are the 45-45-90 triangle, so basically that's an isosceles right triangle, and then there's a 30-60-90 triangle. The trig values that we get from these two triangles are important and are going to help us in this unit. So we're going to make up like a little chart here. In the 45-45-90 triangle, the two sides that are congruent are each 1, and the hypotenuse will always come out to be radical 2. Okay, so if the sides were each 3, the hypotenuse would be 3 radical 2. If the sides were each 5, it would be 5 radical 2. But our example, the sides are 1 and the hypotenuse is radical 2. In the 30-60-90 triangle, the side across from the 30 is 1. The hypotenuse is twice that, it's 2. And the side across from the 60 is just 1 radical 3. All right, so let's try and fill in this chart here based on those triangles. But we do have to rationalize all the denominators. All right, so sine of 30. Let's find the angle that's 30 degrees. Sine, and maybe I'll write this across the top, so katoa. Sine of 30 is opposite, which is 1, over hypotenuse, which is 1/2. All right, that was pretty easy. Cosine of 30, how about we'll do all the ones that are 30. Cosine of 30 is adjacent over hypotenuse. All right, easy enough. And tangent is opposite over adjacent. So opposite would be 1 and adjacent would be radical 3. All right, so now here's a case where I have to rationalize the denominator. I can't leave a radical in the denominator. So I'm going to multiply numerator and the denominator by radical 3, and that gives me radical 3 over 3, because radical 3 times radical 3 in the denominators is radical 9, which equals 3. All right, let's do the 45s. So sine of 45. So I am looking at this angle right here. Sine of 45 is opposite, which is 1 over hypotenuse. All right, I got to rationalize this denominator, radical 2 over radical 2. So that gives me radical 2 over 2. All right, cosine of 45 is adjacent over hypotenuse. Oh, look at that, it's the same thing. So that obviously is going to also simplify to radical 2 over 2. And tangent of 45 is opposite over adjacent, and that's 1 over 1, which just equals 1. All right, then we got our last one left, our 60-degree angle. So I'm going 60 degrees now. Tangent, a sine is opposite over hypotenuse. All right, that's okay if the radical's in the numerator, just can't be in the denominator. Cosine of 60 is adjacent over hypotenuse, 1/2. And tangent is opposite over adjacent, radical 3 over 1, which is just radical 3. All right, so in the past, this chart really needed to be memorized, unless you wanted to draw out the triangles. We're doing everything open notebook, so you guys are fine. All right, so let's flip this over and let's find some exact values of some trig functions. So sine of 30, so you're going to have to look back on that chart. The sine of 30 is 1/2. The cosine of 30 is radical 3 over 2. Okay, again, I'm getting these from looking at the chart right here. Sine of 30 is 1/2, cosine of 30, radical 3 over 2. I'm going to add them together. Well, my denominators are the same, so this is just 1 plus radical 3 over 2. You cannot combine the 1 and the radical 3 and tell me that it's radical 4 or 4 or something like that. That's my answer. All right, here's where it's going to get tricky. Cosecant of 45. Cosecant, remember, is the inverse of sine. So that equals 1 over sine of 45. So really all I have to do is take the sine of 45, which is radical 2 over 2, and flip it. So that's going to be equal to 2 over radical 2. Okay, because sine of 45 was radical 2 over 2. I'll write that up here just in case I lost anybody. And cosecant, I have to flip that. So 2 over radical 2. Now I got to rationalize this denominator. So that's 2 radical 2 over 2. Actually, yeah. All right, I'll leave it like that. I was going to say I can also wait. I'm multiplying. I'm just looking ahead. I'm multiplying this by the tangent of 60. If I wanted to wait to rationalize the denominator, I guess I could have. So tangent of 60, I got to go back, is radical 3. And now I can just multiply. So there's a 1 in front of that radical 3. 2 times 1, I'm multiplying the numbers in front. Radical 2 times radical 3 is radical 6. And 2 times 1 in the denominator is 2. Well, the 2's can cancel, so this answer is just radical 6. All right, so I'm finding the exact values of these trigonometric functions. Exercise 2, if f of x equals sine of x minus secant of x, what is f of 60? So basically, I am doing f of 60. So I'm doing sine of 60 minus secant of 60. Well, sine of 60, look in your chart, is radical 3 over 2. And secant of 60, secant, remember, is the inverse of cosine. And the cosine of 60 is 1/2. So the secant of 60 is the reverse of that. So minus 2 over 1. All right, I cannot subtract these unless they have the same denominator. So 2 over 1, I'm going to change that to 4 over 2. That's equivalent. And now they have the same denominator. All right, there we go. And this one, 3, is a little bit tricky. Just a notation. Basically, we can't write sine x squared. So if I have something like sine x and I want to square it, that really just means sine 2 to the x, right? It's just a notation. So basically, when I have sine 2x, that is really just sine of x squared. And I want to find 45, so I'm doing the sine of 45, and then I will square that. Well, the sine of 45 is radical 2 over 2, and I'm squaring that. That means radical 2 over 2 times radical 2 over 2. And that is radical 4, which is 2, over 4, and that's 1/2. All right, so those were my exact values. The next thing I have to talk about with you is cofunctions. Cofunctions we did talk about in geometry last year. Sine and cosine have a unique relationship. You're going to fill in the table with their decimals rounded to 3 decimal places and then answer the question. So all I'm doing is my calculator. Remember, your calculator needs to be in degree mode when you're doing this. So sine of 20, 0.342. Sine of 30, we already know the exact value was 1/2. I'm going to write it as a decimal though, 0.5. Sine of 45, 0.707. Sine of 60, 0.866. I'm just getting these from the calculator. Sine of 70, 0.940. Now let's do the cosine of 20 is 0.940. The cosine of 30 is 0.866. The cosine of 45 is the same, 0.707. Cosine of 60 is 0.5, and the cosine of 70 is 0.342. Now looking at the table, this is the next question. I can leave the table up there as we do this. When does sine of A equal cosine of B? Well, the sine of 20 equals the cosine of 70. So sine of 20 equals cosine of 70. The sine of 30 equals the cosine of 60. Get another color. The sine of 45 equals the cosine of 45. Okay, so, and the reverse is true also in that let me get a different color. The cosine of 20 equals the sine of 70. and the cosine of 30 equals the sine of 60. What do you notice about angles? What do you notice about angles A and B when the sine of A equals a cosine of B? Well, the angles, look at them. I got 20 and 70, 30, 60, 45, 45, 20, 70, 30, 60. The angles equal 90. A and B are complementary angles, all right? They equal 90. So based on what we just noticed, if the sine of A equals a cosine of 25, what do you think the value of A would be? Well, we noticed that A plus B equals 90, and the B is 25, so I'm really just solving for A. I'm going to subtract 25. That's how easy it is. All right, the sine of A equals the cosine of B if A plus B equals 90. That's the rule. The sine of A equals the cosine of B if A plus B equals 90. All right, so if the sine of 2x plus 1 equals the cosine of 3x plus 4, what is the value of x? Well, we said A plus B equals 90. So 2x plus 1 plus 3x plus 4 equals 90. 5x plus 5 equals 90. Subtract 5, 5x equals 85. Divide by 5, x is 17. All right, so a quick little summary of everything. Sine and cosine are referred to as cofunctions. Their values are equal when their angles are complements. That means when they equal 90. The value of a trigonometric function of an angle equals the value of the cofunction of the complement. The cofunction identities below show the relationship between sine and cosine. So the value of sine of an acute angle is equal to the cosine of its complement. So sine of theta equals cosine of 90 minus theta. An example, sine of 27 equals cosine of 63. Notice those angles have to equal 90. And the reverse is true. It works for cosine. The value of cosine of an acute angle is equal to the sine of its complement. Cosine of theta equals sine of 90 minus theta. Example, cosine of 15 equals sine of 75. All right, and we'll practice all that tomorrow.